So, welcome everyone. Welcome to the session on Mohr Circle. So, this is a continuous session. So, already in this playlist, we have completed composite section and elastic constants. If anybody has not yet watched, you can watch it. That is available in the YouTube, right? So, now we are going to discuss about Mohr Circle here, okay? Right. So let us move into our session. Before that, I need to tell you a simple information. That is India's largest Unacademy combat, which is happening. That means every week this Unacademy combat that is going to be happening, right? Right, okay. So what is special about this Unacademy combat means it is exclusively for students who are preparing for GATE, right? And in the first 60 minutes, you'll be having an access for GATE preparation, and after that a challenging and quite good questions, that is exact GATE questions, will be asked, right? That is typical kind of a GATE questions will be asked as a quiz, and you have to answer those questions on a live. Most important thing is if you enter your answer, the results will be published immediately. That means your leaderboard will be live, exclusively live. That means you are competing with the minds that is across the country. So if you select the right answer, immediately your leaderboard will be updated, right? It's a live compete test, right? And most important thing is, after completing this Unacademy combat, a detailed video solutions that will be provided, which means why it is so important, because right, you can easily identify your mistakes and you can improvise your weakened areas. That is the main advantage here, right? So due to that, you can clarify your doubts, and if there is any issues, or if there is any problem that you have made it during the answering the questions, you can correct your mistakes. And this Unacademy combat, this is happening on June 6, 13, 20 and 27. Right, that means every Sunday, and it starts at 11 a.m. Okay, so if you need to enroll to this Unacademy combat for a free, you have to use the code PSK20. If you use the code PSK20, then you can easily access to this Unacademy combat in the Unacademy app. And not only participating in the Unacademy combat, if you get a good rank, that means if you get a good mark in the Unacademy combat, then you will get an exciting prizes like a complimentary Unacademy Plus subscription, that is 1 year of subscription that will be provided for the students who got rank 1 to 3. And if you get a rank from 4 to 10, 75% of offer that is provided for the students who get the rank 4 to 10 in the Plus subscription. And 50% will be provided for rank 11 to 50. And if you get a rank 51 to 100, you will get 25% of offer in a Plus subscription. So this is an exciting price that is happening. Not only, right, these are the students who got A rank in 2021 GATE examinations under Mechanical, Production and Engineering Science category, and this is for your information, right? Now, there are two types of subscriptions that is available. One is a Plus subscription, another one is a Iconic subscription. So what is special here, right? So in a Plus subscription, you have an access to all the live classes, right? You have an access to all the live classes that is available in the platform under the category which you are getting subscription. And you can also watch the previous recorded sessions also. And crash courses will be there to improvise your weakened areas, right? So here the crash courses will be provided. And every week you'll be having the weekly test. That is, every week you can review what are all the things that you have studied in that week. You can review with these weekly test questions. And doubt clearing session. Every fourth session is a doubt clearing session, which means if you are learning a topic for 3 continuous sessions and the consecutive fourth session, that is exclusively for the doubt clearing. That is, your doubts will be clarified in that session. So it is really useful for the students who are regularly studying, that is on a daily basis. And the courses will be in English and Hindi, and Arabic will be given. Right. And these are the things which you will get in the Plus subscription. If you are going for an iconic subscription, here you'll be having a study planner. That means a perfect study planner will lead to your perfect mark. That is, if your planning is good, then execution is very easy. So planning is very, very important. For that, based on your previous performance, a customized, that is exclusive customized study planner will be provided for yourself. And personalized coach will be there to guide you and to make a best preparation strategy. And dedicated doubt clearing instructors will be there to clarify your doubts. Whenever you are having a doubt, you can post it and your doubts will be clarified. And preparatory study materials will be there to prepare it, and you can download it, which is available in the PDF format, and you can use for your preparation purposes. And study booster sessions, that is just before examination, last minute preparation, a booster sessions will be given to boost your marks, right? To just boost your marks, a booster sessions will be there. That means what are all the essential guidelines that to be followed in the examinations, what is your how should you enter into the examinations, what's your mindset you should have, and how to approach an examinations, how to approach the questions. These will be done regularly by regular workshops. And personalized test analysis, that is in-depth micro level analysis will be done, like section wise, question type wise analysis will be done for your own performance, and it will be provided to improvise your mark. So these are the things which will be available in Iconic. Rather than these things, you will also have this also, right? Okay, right. And next is important thing is price hike, right? Price hike is coming. That means the price of GATE and ESE subscription is going to increase it. So be aware of it and do it today itself. So before, if you subscribe today, you can avoid this price hike. And not only that, in the price hike, after that you will also have this effective version of digital notes. That means and apart from the unlimited access to all the courses, you will also have a digital notes, right? So now you can ask me whether if I subscribe now, if I have an access to this. Yes, you will be having an access to this with the current price, but later the price will be high. Price will be high for this also, right? Good. And these are the subscriptions that is available, right? Okay, now GATE and ESE subscription for 1 month, 3, 6, 12 and 18 months, that is available. If you go for a subscription page, it is available like this. Now here, if you use this referral code PSK20, if you use this referral code PSK20, immediately you'll have a 10% discount, right? That is PSK 20. PSK 20, right? Remember the code. If you use the code, you will get a immediate 10% discount, right? For all kind of subscriptions, right? And a batch course which is going to be happen here, that is on 23rd June. So what is special about this batch course means, right? All the fundamentals from the basics, it has been planned. So your fundamentals, theory part of each topic, previous year questions on the topic, multiple choice questions, numericals, everything will be discussed on a specific topic from fundamentals. And most important thing, your complete syllabus will be covered. You don't need to try to watch any other videos. If you follow this one batch course, in this batch course, your complete syllabus will be covered. Right? It is a pack, right? So every day you have to spend 2 hours to 3 hours of time to watch the videos in this batch course. So it will be updated regularly with the previous year questions, and also tests will be provided. So if you are planning for a 2022 or 2023 examinations, this batch course is a perfect study planning. So if you follow it every day, you have to spend only 2 hours to 3 hours. So surely it will help you to make it. And if you need to go for this batch course, you have to use the code PSK20 to access to this batch course for a subscription, right? And also you'll get a instant 10% discount, right? Good, right? So let's move on to our topic, that is Mohr Circle. Before going into Mohr Circle, right? Before starting into the Mohr Circle, where these are the analytical equations, because we are having two types of techniques. One is a analytical method, another one is a graphical method. We can solve problems, that is, we can solve numericals by using either analytical method or graphical method. Where in analytical method we need these equations to solve the problems in an oblique plane, that is load acting on an oblique plane. We need these equations. So for a graphical method we can solve by using graph, that means by using drawings. And in that graphical method only Mohr Circle is a part. So before going into graphical method, I need to give you a simple information that is about analytical method. So these are the formulas which is used for 4 different kind of loading conditions, right? So in a component, only one direct stress is applied, that is in the x direction. Only one direct stress is applied in one direction. So the normal stress equation, tangential stress equation, and maximum shear stress equation, right? Same way, two direct stress that is applied in a mutually perpendicular direction. When two direct stress that is applied in a mutually perpendicular direction, then the equation is given. For a simple shear, equation is given. Now combining two direct stress plus simple shear. So if you combine these two, you'll have this equation, right? So these are the 4 different kind of loading conditions where you will have a normal stress, tangential stress, and maximum shear stress equation. Now parallelly, you can solve the problems by using this method, this analytical method, or you can also do it by a graphical method. Now we are going to concentrate on graphical method, that is Mohr Circle. Right. So where Mohr Circle is used? So where Mohr Circle is used? Body subjected to a two mutually perpendicular principal stresses of unequal intensities. When a body subjected to a two mutually perpendicular principal stresses of unequal intensities, then you can use a Mohr Circle. There are 3 conditions. One is when a body which has two mutually perpendicular principal stress intensities where their intensities are unequal. Where their intensities are unequal. Right? This is the representation here. Same way, next one, second one, when a body is subjected to a two mutually perpendicular stresses which are unequal and unlike. Right. So unequal and unlike means sigma 1, sigma 1, sigma 2, sigma 2. That is, sigma 1 is not equal to sigma 2. Yes, sigma 1 is not equal to sigma 2. Right. And also you can see here sigma 1, sigma 2 both are tensile. Similarly, here it can also be compressive. That means either 1 and 2, both are either tensile or compressive, right? But on the second condition, 1 is tensile, 2 is compressive, or else 1 may be compressive, 2 is tensile. So it is unlike stresses. That is the meaning of unlike stresses. Unequal intensities means their magnitude is not equal. Okay, so this is the second condition. And third one is when a body is subjected to two mutually perpendicular principal stresses with shear stress. That means right, so with shear stress, so we have to calculate with shear stress, right? Okay, so we are going to discuss these three type of loading conditions. Okay, good, right. So first one, two mutually perpendicular principal stresses of unequal intensities. That is the first thing. So where sigma 1 means major tensile stress, sigma 2 means minor tensile stress. Sigma 1 is major tensile stress, sigma 2 represents the minor tensile stress, where theta is equal to angle made by the oblique plane with axis of minor tensile stress. Okay, so angle made by oblique plane with axis of minor tensile stress, because most of the students will make mistake at this point, right? So theta represents this is theta, that is angle should be taken, that is angle should be taken from the minor axis, that is vertical axis. Angle should not be taken from the horizontal axis, right? Please remember, because in the previous year questions, the theta that is given in the graph, it is given from the major axis, so you have to convert it to minor axis. How? Just 90 degree. 90 degree minus angle that is given, you will get the theta value. Okay, right. So sigma 1 major, sigma 2 minor tensile stress, where one, two, right? 1, 2. Okay, so angle made by oblique plane with axis of minor tensile stress, right? So how to draw this Mohr circle? I think everyone know how to draw this Mohr circle. I'll quickly brief it and we will move on to the previous year questions. Okay, right? So if you know the major and minor principal stresses from A to point B, this is point B, right? From A to point B, draw a line, and it represents the major tensile stress. And in that AB line, mark a point C, where from A, the C point, AC represents the minor tensile stress value. Here, both are equal, means both are like stresses, both are either tensile or both are either compressive. That's why we are drawing like this, right? Now, AC represents minor tensile stress. Once it is drawn, then find a center point between C and B, right? And based on the center point, we named as O. Now OC or OB as radius, draw a circle, and that is the Mohr circle, right? Okay, that is the Mohr circle. Now from here, from the center point O, draw a line that should touch the Mohr circle, where the angle is 2 theta. Angle is 2 theta. From that point E, draw a vertical line perpendicular to AB and it touches at D. And from E, join A, from E, join C. Now the values AD represents the normal stress, ED represents the tangential stress or a shear stress, AE represents the resultant stress. Simple, right? So same thing that we have done it here. Normal stress, tangential and maximum shear. Right? Same equation. If you use it, you will get the answer. Right? Now coming to the other part, that is second type. Two mutually perpendicular stresses, unequal and unlike stresses. Okay, unequal and unlike stresses. So unequal stresses and unlike stresses means sigma 1 is maximum principal stress, sigma 2 is minor principal stress, where sigma 1 is tensile, sigma 2 is compressive. Let's take it like this. And from the point A, I am drawing a line up to B. And AB represents the maximum principal stress, AB represents the maximum principal stress or a tensile stress. And from A to C, AC represents the compressive stress. Right? AC represents the compressive stress. Right. Now, from this distance, CB, right? Find the center point. Distance of CB, center point is O, right? And from O, draw a line that should touch the Mohr circle, right? Okay, so again I'm repeating from the first. Distance AB represents the sigma 1, that is major principal stress, and it is tensile. So from the origin we are drawing right hand side, where sigma 2 is compressive. So from the origin we are drawing left hand side because it is compressive. So AC represents the minor principal stress. So there's line CB, find the midpoint of CB, that is O, and now OC or OBS radius, draw a line, draw a circle, that is your Mohr circle. From O, draw a line which should touch the Mohr circle, and the angle of this line is 2 theta, right? And from the point E, draw a vertical line up to D, and from E, joint C, joint A, right? Now again, AE represents the resultant stress, AD represents the normal stress, ED represents the tangential stress or a shear stress, right? Right, great. Now, when a body which is subjected to two mutually perpendicular principal stress with simple shear stress, okay, with two mutually perpendicular principal stress with simple shear stress, that is the one. So sigma 1, sigma 2 with shear stress, that is given. Sigma 1, sigma 2 with shear stress is given. So major tensile stress, minor tensile stress, shear stress, and angle made by the oblique plane theta. As usual, it is given. So for this, how to draw a Mohr circle? So same way, AB represents the sigma 1, right? And AC represents the sigma 2. So we are having both values, sigma 1 and sigma 2, AB and AC. Now, from CB, from C and B, from C, draw a vertical line up to G. From B, draw a vertical line up to F. So what is the representation? The value of shear stress. So it represents the value of shear stress. So the line CG must be perpendicular to AB, the line BF should be perpendicular to AB. So BF and CG is equal, the distance is equal. Now from G join F. From G join F. Now the line GF coincides the line AB at point O. Now mark it as O, and from that O take 2 theta. The 2 theta means OF. From OF 2 theta and draw a line which should match E, which should merge with E. So from E, as usual, draw a vertical line and draw a line that should match with join the A. So AD represents the normal stress, ED represents the tangential stress, AE represents the resultant stress. So these are the drawings. So 3 type of loading conditions, 3 type of Mohr circles, right? So with these conditions, it's been very easy to solve the problems. How? Let's go to the first one. Why? Because we have studied, right, what is the equation of principal stress, right? What is the equation of principal stress, right? We know that at the axis, at the principal stress axis, the shear stress will be 0. Maximum principal, that is maximum principal stress. At maximum principal stress, shear stress will be 0, right? Got it? At maximum principal stress, shear stress will be 0. Here we are saying AD is the maximum normal stress. AB represents the normal stress, right? And ED represents the shear stress. When shear stress is 0, when E point, when ED line becomes 0, when ED line becomes 0, when this ED point slowly moves and when it touches at B, when the point E touches at B, then the distance ED is also become 0, right? Okay, ED will also become 0. That means maximum normal stress. Maximum normal stress is equal to the maximum principal stress. That means maximum stress that is possible is AB, because that is the distance, maximum distance of the circle, right? So AB is the maximum possible, right? AB is the maximum possible, right? So how you can attain this? When E merges with C. Similarly, what is the minimum principal stress? Let's take it as sigma 1. Right, minimum principal stress. When E merges with C, where you get the minimum principal stress. So maximum principal stress, minimum principal stress, right? So that is the first one. Next is maximum shear stress. So shear stress means ED, right? ED represents the shear stress. So what is the maximum value of possible ED value? When D merges with O, when D merges with O, then that is the maximum value of ED. Because what could be the maximum value here? That is radius of Mohr circle is the maximum possible value. That is G, right? Let's take it as G. That is GO, ROC, ROB, ROE, right? Everything is radius, right? OE is radius, OB is radius, OC is radius, right? Or GO is radius. So radius of Mohr circle is the maximum possible value of shear stress. So that's why the equation is taken like maximum shear stress means radius of Mohr circle. Okay, right? Got it? right? So these are the two simple shortcuts. So when maximum principal stress, the shear stress is 0 because ED value becomes 0. Similarly, minimum principal stress, the ED value becomes 0. At maximum principal stress, then the principal stress values will be in between. Okay, right? Which the maximum shear stress is equal to radius of Mohr circle. Okay, right? So these are the shortcuts. So let me show how to use these shortcuts in your examinations, right? Okay, with the previous year questions. Okay, right. Now let's go to the first question. In a Mohr circle, radius of Mohr circle is taken as, that's the question. It is asked in both IAS and GATE, where sigma x, sigma y represents the normal stresses along x and y directions, and tau xy represents the shear stress, right? Tau xy represents the shear stress. So according to that, here the answer is A. That means radius of Mohr circle is equal to maximum shear stress, that is equal to x minus y by 2 whole square plus tau xy square. So this is the answer, right? So we know maximum shear stress equation, that is equal to radius. So if radius is asked, you can substitute here and you can answer, right? And next question, another super good interesting question where the answer is B. Just read out the question. You can find that how much interesting the question is, right? A two-dimensional fluid element rotates like a rigid body. Okay, rotates like a rigid body. At a point within the element, the pressure is 1 unit. At a point within the limit, pressure is 1 unit. Radius of Mohr circle characterizing the state of stress, that is the question. And I have already mentioned radius of Mohr circle, that is equal to maximum shear stress, that is equal to x minus y by 2 whole square plus tau xy square, where pressure of 1 unit is applied in a fluid, means it's a fluid where pressure of 1 unit is applied, which means sigma x is equal to sigma y on both directions. That means on x and y directions the stress will be same. How? Because in a container the pressure is common, right? We know that the pressure is common in a container, right, based on Pascal's law. Okay, so x and y are equal. We can rewrite it as equal intensities and like stresses. So both conditions satisfied. Equal intensities, both are like stresses. That means both are tensile, right? That means acting away, right? So they are tensile, which means when both values are equal, what will happen if you substitute it here? So x minus y by 2 whole square plus tau xy, right? So shear stress, and I can rewrite it like this. Let's take it the value as x. and shear stress is 0 because there is no shear stress is applied. So now x minus x by 2 whole square plus 0 square, which is equal to 0. Right, now you can see maximum shear stress, that is equal to radius, that is 0. Okay, when you will have this value, when equal intensities and like stresses. If you are having a equal intensities and like stresses, simply you can take it maximum shear stress 0, so radius of Mohr circle is also 0. So based on conditions, you can quickly answer it. That is the simple shortcut for this question, right? Okay. Next one. So this is another most interesting question, which is asked in 2012 GATE, where the state of stress at a point under applied stress condition, sigma x is given, sigma y is given, tau xy, that is also given, right? So (40 megapascal, 100 megapascal, 40 megapascal. So the question is all about calculate the radius of Mohr circle. So radius of Mohr circle, that is equal to maximum shear stress, so which is equal to x minus y by 2 whole square plus tau xy square. So the values are 40 minus 100 by 2 whole square plus 40 square, that is equal to minus 30 square plus 40 square, that is equal to 50 Newton per mm square, or megapascals. You can write it as megapascals. So what I'm already said, this is the answer, and the interesting part is a few numbers like 3 square plus 4 square is equal to 5, right? And this is repeatedly used in GATE. You can see not only in strength of materials, even in other courses also, the numerical value 3 square plus 4 square value has been used multiple times, right? So 3 square plus 4 square is 5. So there are few other things like this, like 6 square plus 8 square, right? That is equal to 10, right? So there are few other things also there. So please remember, and this is most commonly used one, right? Most commonly used right? So here the answer is 50. That is B is the right answer for this GATE 2012 question. Okay, right. So going to the next question. Yes, another super interesting question, where Mohr circle of state of stress, that is given. So this values represent sigma x and this represents sigma y. So sigma x is 30 megapascal, sigma y is 30 megapascal. Both are given as 30 and 30 megapascal, right? So the question is in 2006 question paper. Now you have to calculate the center point of Mohr circle and radius of Mohr circle. So first we will calculate the radius. Radius is equal to maximum shear stress, that is equal to x, sorry, it's minus minus y by 2 whole square plus tau h. So x is 30 minus 30 by 2 whole square plus shear stress is not given, that is also 0. That is equal to 0. So it is being clear that the radius of Mohr circle is 0. Now with this answer itself you can identify D is the perfect answer, because all other options, that is option A has 30 megapascal as the answer, and option C radius is 30 megapascal, option B radius is 60 megapascal. So here itself it is clear that D is the right answer, because only option D has radius, that is option D has 0 radius. Okay. It has a 0 radius, right? Now you have to find the center point. So how to find the center point? Very simple. So I'm going to do different conditions where center point means AO, right? AO you have to calculate. AO is the center point here. Now how to find this AO value? AO is equal to AB plus AC by 2, that is two extreme ends. AB is the extreme end of this Mohr circle, AC is the left extreme end of the Mohr circle. So you have to take it down two extreme ends. So AB plus AC divided by 2, right? So this is for two mutually perpendicular principal stresses of unequal intensities and like stresses, right? Okay, so you would get the answer here. Same way here, what will happen, right? So how to find the value of distance AO, right? So which is also same, where AO, that is center point, is equal to AB plus AC by 2, where this AC should be represented as negative, because AC is compressive, right? AC is compressive. Minimum principal stress is compressive. That's why you have to represent minus. In case if major principal stress is compressive, then you have to substitute the AB value as negative. So based on the type of stresses, you have to substitute whether it is positive or negative. But the common equation is AB plus AC by 2. Common equation, like in previous also AB plus AC by 2, here also AB plus AC by 2. If it is compressive, use negative side, whether it is AB or AC. That is major principal stress or minimum principal stress, use negative side. So according to that, here if you go into the next question, that is center point AB plus AC by 2. What is AB? That is maximum principal stress, minimum principal stress divided by 2. Okay, so 30 plus 30 by 2, that is equal to 30 megapascal. So the correct answer here is 30 megapascal is the right answer. Means 30 megapascal is 30 units. So because in graph we will convert it to units as how we are drawing the Mohr circle. That means 30 units is the right answer. So I have calculated the x-axis, right? So I have given the center point, calculation of x-axis 30, and you can see yes, the x-axis value that is clearly mentioned as 30. That's clear, right? Now what about y-axis? So now you can see y-axis. This is for x-axis. What about y-axis? Y-axis, always it should be 0. What is the meaning of 0? Always the center of Mohr circle lies on the horizontal axis. Please remember it. Most important thing here, always the center of Mohr circle, that is O, lies on the AB only. It will not move downward or upward, which means y-axis, it is always 0. That is center point of Mohr circle. Y-axis always 0, and x-axis, here is the equation. So if you go to the next one, here also y-axis is 0. So whenever center point of Mohr circle is asked, y-axis is 0, x-axis we are having formed. So now we have calculated the center point and radius of Mohr circle. Both are given. So hope this question is very, very interesting one. Right? Great. Nice. So next one. Fifth question. Yes, another such an interesting. So this figure which shows the type of stress that is acting. The magnitude of stresses x and y direction is given. That is 120 megapascal. Radius of Mohr circle you have to calculate. So in x direction it is 100 megapascal and y direction 20 megapascal. Right. Now most important thing is here, y is compressive, because you can see the direction of stress. Y is compressive and x is tensile. X is tensile. So if you need to calculate the radius of Mohr circle, that is equal to maximum shear stress, that is equal to x minus y by 2 whole square plus tau xy square root. So if you substitute the values, that is x is tensile 100 megapascal, y is 20, that is compressive, so minus 20 divide by 2 whole square, and shear stress, that is not given, right? So shear stress value, that is equal to 0 square root, that is equal to 100 minus of 20, so 120 divided by 2 whole square plus 0 square, that is equal to 60 square root or 60 megapascal. So the final answer is 60 megapascal. That means C is the right answer for this question. Got it? Done? Right? So these are the quite very good interesting questions in Mohr circle, and the question is asked in 2004 GATE. So if you know the simple basic fundamental concepts of Mohr circle, the time taken to answer the question is very, very less. That is, even you can answer it within 20-30 seconds. And most interesting and useful topic. And why I'm saying this is more important means, if you take last 20 years of question paper, you can see that combining GATE and ESE, we are totally having 21 questions from this Mohr circle. So 21 questions from the Mohr circle. So that much important Mohr circle topic is, right? Okay, so don't miss out this topic, and hope the session is very interesting, and we will see on our next session, right? Thank you.